So here's the last piece of number 2 from the 2012 AB exam. And in part C here, they want us, and my calculator before I get rid of it, and, this is just the intersection that we used in part A and part B, so I have that on the screen already, but I don't think we'll need the calculator for the rest of this because it just asks us to write but do not solve anything. Anyhow, in part C it says, let the horizontal line y equal k divide R into two regions of equal area. So we have from part A the area of region R. If I click back to that real fast, the area that we wrote down for part of region R from part A is 2.986. So we know the area of region R is about 2.986 square units. What we want to do in part C here is we want to write but do not solve an equation involving one or more integrals whose solution gives the value of k. So k is going to be a horizontal line that cuts the region into two pieces. The piece up here, the piece that's above that intersection, and the piece that's below that intersection are going to have equal areas. Now the sum of those areas, the sum of the area that's shaded in red and the sum of the area that's shaded in green, that's going to have to give you 2.986, the area of R. So what I'm going to do is I'm going to focus on the area that's shaded in green. And if I get rid of that so that I can do a little bit of doodling within that region, if I take a horizontal slice of that piece of region R that's below this y equals k line, and I wanted to find the area of that, my horizontal slice, if I approximate it to be a rectangle, the height is a tiny, tiny difference in y values, tiny, tiny vertical dimension from the coordinate plane, and then my difference in x's for my width, right? My bigger x would be over here, my smaller x would be over here. So I'm going to take the right-hand x value, which from part A I think we determined that as an x value, the equation of the line was x equals 5 minus y. So I'm going to take 5 minus y, and then minus the left-hand x value. Well, the left-hand x value, when you solve this equation for x, gives you e to the y. If you're concerned about any algebra, go check out the video for part A, and I did some of the algebra there that we'll kind of bypass in part C here. So the area that's in green would be found by taking the integral of this expression, 5 minus y minus e to the y, with respect to y, and then we'd have to figure out what to put on as our limits of integration. Well, our limits of integration have to be y values, and the y values that all slices like this green one would range between are this y value, which is y equals 0, and this y value right here, which is y equals k. So if we do this integral, that will give us the area that's beneath that line, y equals k, that's within the region R. We know that this answer has to be half of the area of region R, half of 2.986. So here's an equation right here involving an integral. So here's an equation involving an integral that, if we solved it, would find the value of k that cuts region R into two pieces of equal area. We could have focused on the region that was shaded in red here, and if we had done that, we'd have really the same expression for the width of one of our red slices, right? Right-hand x is still on the line, left-hand x is still on the curve. So we'd still have this times delta y for the area of that type of slice, but the limits of integration would go from k up to this y value, 1.3065. And that would also have to equal 1/2 of the area of region R.